In this lecture, we will understand what is multiple tone amplitude modulation and its various characteristics like total power, efficiency, current and voltage of the multiple tone amplitude modulated signal. Let's say carrier signal Ct is equal to AC cos 2 pi fct, and let's consider a multiple tone modulating signal or message signal having three terms, or mt is equal to a1 cos 2 pi fm1 into t plus a2 into cos 2 pi fm2 into t plus a3 into cos 2 pi fm3 into t. So the multiple tone amplitude modulated signal can be given by yt is equal to AC plus mt into cos 2 pi fct. Put the value of mt in the equation, then it can be written as yt is equal to AC plus a1 into cos 2 pi fm1 t plus a2 into cos 2 pi fm2 t plus a3 into cos 2 pi fm3 t into cos 2 pi fct. Take AC common from the equation, then the multiple tone amplitude modulated signal can be written as yt is equal to AC into 1 plus a1 by AC cos 2 pi fm1 into t plus a2 by AC cos 2 pi fm2 into t plus a3 by AC cos 2 pi fm3 into t into cos 2 pi fct. Identify this as equation number 1. Now, according to the definition of the modulation index, a1 by AC is equal to m1, a2 by AC is equal to m2 and a3 by AC is equal to m3. If the multiple tone amplitude modulated signal had a number of terms, then the equation 1 can be written as yt is equal to AC into 1 plus a1 by AC cos 2 pi fm1 into t plus a2 by AC cos 2 pi fm2 into t until the n number of terms, which is an by AC cos 2 pi fm1 into t into cos 2 pi fct, which can be simplified as yt is equal to AC into summation of k is equal to 1 to k is equal to n AC by k into cos 2 pi fmk into t into cos 2 pi fct. Then the modulation index can be written as a1 by AC is equal to m1, a2 by AC is equal to m2 until an by AC is equal to mn. So the equation of the amplitude modulated signal from the equation 1 looks like this. Now remove the bracket and multiply AC and cos 2 pi fct with every term. Finally, multiple tone amplitude modulated signal can be given by, identify this as equation number 2. Here first term is AC cos 2 pi fct, which is the carrier signal. Second term is AC into m1 into cos 2 pi fm1 into t into cos 2 pi fct is the equation of the first sideband, and AC into m2 into cos 2 pi fm2 into t into cos 2 pi fct and AC into m3 into 2 cos twice pi fm3 into t into cos twice pi fct are the second and third sideband. Now all the signals are cosine signals. We know that the power of the cosine signals is equal to Vrms square by r, which can be replaced by Vm by root 2 whole square by r, where Vrms is the RMS value of the cosine signal and Vm is the amplitude of the cosine signal. Here the amplitude of the carrier signal is AC, so the power of the carrier signal is equal to AC divided by root 2 whole square by r, which can be simplified as AC square by 2r. Power of the sideband signals. Here the first sideband term in the equation 2 is AC into m1 cos 2 pi fm1 into t into cos 2 pi fct. Now multiply and divide by 2 and the equation becomes, apply the formula of 2 cos a cos b, which will result in AC into m1 divided by 2 cos twice pi fm1 minus fc into t plus cos twice pi fm1 plus fc into t. Open the bracket and multiply AC into m1 by 2 with both the terms. Now the sideband is the sum of upper sideband and lower sideband. Total power of the first sideband will also be the sum of power of upper sideband and power of lower sideband. As both the sidebands are cosine signals, we can apply the formula of power of cosine signal for the calculation of power, which is Vm by root 2 whole square by r. Now put the amplitude of the upper and lower sideband as AC into m1 divided by 2, then add the two terms, and then it becomes 2 into AC into m1 divided by 2 root 2 whole square by r. Simplify the equation, then power of the first sideband is equal to 2 into AC square to m1 square divided by 8r. Then the power of the first sideband can be simplified as AC square into m1 square divided by 4r. Similarly, for the second sideband, equation is AC into m2 into cos 2 pi fm2 into t into cos 2 pi fct. Again, multiply and divide the equation by 2. Then the equation becomes AC into m2 divided by 2 into cos 2 pi fm2 into t into cos 2 pi fct. Again, after applying the cosine rule of 2 cos A cos B, the signal becomes sum of upper and lower sideband. Again, the total power of the sideband is the sum of the power of upper sideband and power of lower sideband. Similarly, by adding and simplifying, the power of second sideband is equal to AC square into m2 square divided by 4r. Similarly, for the last sideband, the equation is AC into m3 into cos 2 pi fm3 into t into cos 2 pi fct. Again, divide and multiply the equation by 2, then the equation becomes, again after applying the cosine rule of 2 cos A cos B, the signal becomes sum of upper and lower sideband. Again, if we apply the same procedure for the last sideband, then the power of this sideband can be calculated as P is equal to AC square into M3 square divided by 4R. Now, the total power of the sideband is the sum of the individual power of 3 sidebands, or the sideband power PS is equal to power of first sideband or PS1 plus power of second sideband or PS2 plus power of third sideband or PS3. By putting the value of this equation, PS is equal to AC square into M1 square divided by 4R plus AC square into M2 square divided by 4R plus AC square into M3 square divided by 4R. Take AC square by 2R common from the equation, then it can be written as sideband power PS is equal to AC square by 2R into M1 square by 2 plus M2 square by 2 plus M3 square by 2. Now substitute PC, which is the carrier power, for AC square by 2R, then it can be written as sideband power PS is equal to PC into M1 square by 2 plus M2 square by 2 plus M3 square by 2. Take 2 common from the equation, then it can be written as PS is equal to PC by 2 into M1 square plus M2 square plus M3 square. Identify this as equation number 3. Let's say M square is equal to M1 square plus M2 square plus M3 square. Then equation number 3 can be written as PS is equal to PC by 2 into M square. If there are n number of terms, then the equation 3 can be written as sideband power PS is equal to PC by 2 into M1 square plus M2 square plus M3 square up to the term Mn square. So modulation index M square is equal to M1 square plus M2 square plus M3 square up to Mn square. Now, the total power of the multiple tone amplitude modulated signal is the sum of carrier power and the sideband power, or P is equal to carrier power PC plus sideband power PS. Replace the sideband power as PC by 2 into M square. Take PC common from the equation, then the total power P is equal to PC into 1 plus M square by 2. Replace the M square by M1 square plus M2 square plus M3 square. Identify this as equation number 4. If there are n number of terms, then the equation number 4 will become P is equal to PC into 1 plus half into M1 square plus M2 square plus M3 square after the term Mn square. Now, let's calculate the efficiency of the multiple tone amplitude modulated signal. Efficiency eta is equal to the usable power by total power. Usable power is the power of sidebands, so the eta will become power of sidebands divided by total power. If we replace the mathematical equation of power of sidebands and total power, then the equation of eta will become PC by 2 into M square divided by PC into 1 plus M square by 2. Eliminate PC from numerator and denominator, then efficiency is equal to M square by 2 divided by 1 plus M square by 2. Simplify this equation as eta is equal to M square divided by 2 plus M square. Now, let's calculate the current in the multiple tone amplitude modulation. For multiple tone amplitude modulation, total power P is equal to PC into 1 plus half into M1 square plus M2 square plus M3 square. Replace P by I square into R and PC by IC square into R. Then the equation will become I square into R is equal to IC square into R into 1 plus half into M1 square plus M2 square plus M3 square. Eliminate R from both the terms, then it will become I square is equal to IC square into 1 plus half into M1 square plus M2 square plus M3 square. Now, which can be simplified as I is equal to IC into root over 1 plus half into M1 square plus M2 square plus M3 square. Now, let's calculate voltage in the multiple tone amplitude modulated signal. Now from the equation number 4 we can write total power P is equal to carrier power PC into 1 plus half into m1 square plus m2 square plus m3 square. Replace P by V square by R and PC by Vc square by R. Then the total power can be written as V square by R is equal to Vc square by R into 1 plus half into m1 square plus m2 square plus m3 square. Eliminate R from both the sides, simplify the terms, then voltage in the multiple tone amplitude modulated signal can be written as V is equal to Vc into root over 1 plus half into m1 square plus m2 square plus m3 square. Let's see multiple tone amplitude modulation by using MATLAB. Here we will produce message signal as a sum of 3 signals and the high frequency carrier signal. Finally, by using message signal and the high frequency carrier signal, we will generate the multiple tone amplitude modulated signal. As we can see here, generated 3 individual signals sums up to produce the combined message signal, and there is also generation of a high frequency carrier signal. Now these 2 signals are used to generate a multiple tone amplitude modulated signal. Let me show you modulated signal in a bigger window. You can produce undermodulated, perfectly modulated and overmodulated signal by changing the modulation index or by changing the value of M1, M2 and M3. You can also calculate power, efficiency, current and voltage by putting the formulas that we have proved earlier. You can take more than 3 signals and plot it by yourself. To get this MATLAB code, subscribe to my channel. If this video receives more than 30 likes, then I will provide a link for the code in the description box. Thanks for watching. See you in the next one. That's all for this lecture. If you have any doubts regarding this lecture, then you may ask it in the comment section. And don't forget to hit the subscribe button. See you in the next one.